In this video, we will demonstrate how to install the Dispersion Technology DT-300 Zeta Potential Probe for concentrated suspensions and emulsions. The DT-300 is comprised of two components, an electrical unit which houses all of the necessary electronics, and the sensors which are used for making measurements. These sensors include Zeta Potential Probe, Aqueous Conductivity Probe, which is optional, Temperature Probe, which is also optional, pH Probe, which is optional as well. There are several types of stand for accommodating these probes, allowing for sample handling with or without mixing, as well as minimizing sample volume. This stand is suitable for samples when no mixing is necessary. The Zeta Potential Probe is mounted in it face up, and the sample cup is placed on top of it. The sample then goes inside of this cup. Sample volume for this setup is 5 milliliters when the Teflon cup is used, and only 0.2 milliliters when this metal cup is used. Alternatively, the Zeta Potential Probe, along with the other probes, can be installed in this stand. This setup allows a magnetic mixer to be used to mix the sample. The Zeta Potential Probe can be installed in this enclosed fixture, which allows the sample to be pumped by a peristaltic pump. There is also the option of adding a titration feature with two burettes. This model, with two burettes included for titration, is the DT-310. Finally, the Zeta Potential Probe can be used for measuring porous materials. The models that include this feature are the DT-330 and DT-350. Porous materials can be measured using a special sample cup for porous particles, or by touching the probe directly to the face of a saturated porous monolith. Part 1. Setting up the instrument. There are several connecting ports on the rear of the electronics unit. The mouse and keyboard are plugged into the two USB ports located on the back. There is an additional USB port on the front of the instrument which can be used for a flash drive. The monitor is connected via an HDMI port located here, and the power cable is plugged in here. At the bottom of the rear of the electronics box are a series of ports for the sensors of the DT-300. The amount of ports here varies depending on the options purchased with the instrument. All sensors can be plugged in by hand, requiring no additional tools. Be sure, when plugging in the sensor cables, to properly align the plug with the port in order to avoid cross-threading. The ring on the plug is turned clockwise until it locks into position. You should feel it click into place when the plug is fully connected. Once everything is plugged properly into the DT-300, the instrument can be turned on. The green button located on the front of the instrument is the power button. Press it once to turn on the instrument. When the DT-300 turns on, it will go through a series of steps. First, it will load Windows. After Windows has finished loading, a DOS screen will appear, which runs through a series of checks. After all of the checks have been completed, the DOS window will disappear and the instrument will be ready for use. Be sure to wait for the completion of this DOS checklist before starting the DT software. Now that the instrument has fully booted up, the instrument has been fully installed and is ready for use. Part 2. Making measurements. The first step in making measurements using the DT-300 is to open the Dispersion Technology measurement software. The icon for this software is located on the desktop and can be opened by double-clicking on it. Once loaded, 3 windows will appear on the desktop. The first window is a welcome window, letting the user know that the software has been started and is in the process of booting up. The second window is the instrument status window. This window lets the user know which options are included and available on their instrument. The software takes about 2 minutes to start up, running through a series of checks with the necessary boards and drivers of the instrument. Upon completion, we are left with only the third window, the home screen. The home screen is divided into two sections. On the left-hand side, with the green background, is the experiment design section, where we designate what kind of measurement we want to make. Since this instrument is a DT-300, we will be making zeta potential measurements. If we wanted to make multiple measurements or run a titration, we would designate so in this section of the home screen. On the right-hand side, with the orange background, is the sample definition section. Here we define the samples we're measuring, the liquid medium, the dispersed phase, and the concentration of the dispersed phase. We can also include a sample ID for the measurement, which helps with record keeping and allows for this data to be more easily found in the database later. We will now demonstrate how to make a measurement of 10% silica ludox. We first load the sample cup with our solution. We then define the experiment we plan to run. Since we are going to make a zeta potential measurement, we click the checkbox labeled CVI for zeta potential. We then move to the sample definition section and define our sample. We set the liquid media to water, the dispersed phase to silica ludox, and the concentration to 10 weight%. Lastly, we click the large Run button to begin the experiment. A window will appear asking about the size of your dispersed phase. If the particles, or droplets in the case of an emulsion, are smaller than 300 nanometers, you can select the first option. If they are larger, input the correct size and select the second option. Ludox particles are only 30 nanometers in size, so we can select the first option. Zeta potential measurements are quick measurements, taking between 30 seconds and 2 minutes depending on the nature of the sample. Upon completion, an analysis window will appear which reports the measured zeta potential for your sample. Here we see the zeta potential of 10% silica ludox is negative 38 millivolts, as expected. Part 3. Verification. There is a form that allows for verification that the probe is functioning properly by displaying the signal level at different junctions inside of the probe. This form can be reached from the home screen by selecting View, Grid Raw Data. This will bring up the Grid Raw Data window. On this form, we select View Sensor Level. You can find a snapshot of this form with proper values for different junctions in the manual. Part 4. Calibration. In order to determine accurate zeta potential for your samples, the DT-300 must be calibrated. Zeta potential calibration is done with the same 10% silica ludox that we used in the prior section. In order to calibrate the instrument, on the home screen we select Calibration, Zeta Potential. A separate window will appear. From the drop-down box, we select 10 weight% silica ludox as the standard we are going to use for calibration. We make sure that our probe is properly submerged in our solution, and then we click OK. The instrument will then perform a calibration measurement. Upon completion, the instrument will report the measured zeta potential and CVI phase. These values should be within 1 millivolt and 1 degree of the standard values. If they are, click OK and you are good to go. If not, press OK and then repeat the calibration experiment until those values are within the acceptable range. Once you've completed calibration, your instrument is ready to go and you can begin making measurements of your samples. For more details on how to operate the Dispersion Technology DT-300, an operating manual is stored on the instrument itself. It can be reached by going to Help, Operating Manual, PDF format. We hope you have enjoyed this brief video about the Dispersion Technology DT-300. If you have any additional questions, you can email us at info@dispersion.com. Thank you.